Hello science fans, Bill Nye here, and today we're about to embark on a journey into one of nature's most awe-inspiring and sometimes terrifying forces. Today, we're diving into the science of tsunamis, those massive, fast-moving waves that can reshape coastlines in minutes, leaving a lasting mark on both the land and the people who live there. People sometimes call them tidal waves, but that's a misnomer. Tides are caused by the gravitational pull of the moon and sun, gently moving water back and forth each day. Tsunamis, on the other hand, are triggered by sudden dramatic disturbances in the ocean, like underwater earthquakes, volcanic eruptions, or even landslides. Imagine shoving a toy boat in a bathtub. The splash is like a mini tsunami. That sudden push sends energy through the water, creating waves that ripple outward in all directions. Now scale that up to the entire ocean. Instead of a toy boat, picture a massive chunk of the seafloor shifting in an instant, displacing billions of tons of water. A tsunami moves the whole column of water, from the surface all the way down to the ocean floor. Unlike regular waves, which only affect the top layer, tsunamis carry energy through the entire depth of the sea and can travel as fast as a jet airplane, sometimes up to 500 miles per hour. When it nears land, the wave slows down, but it grows dramatically in height, transforming into a towering wall of water that can sweep away everything in its path. This is when tsunamis become far more dangerous and destructive. The word tsunami comes from Japanese. Tsu means harbor. Nami means wave, because these waves are most destructive in harbors and bays, where the water can funnel and amplify their power. Ancient communities noticed that calm seas could suddenly turn deadly, with little warning. This inspired the name and led to centuries of stories and legends about the ocean's unpredictable might. Today, we'll explore what causes tsunamis, how they travel across vast distances, and what happens when they finally reach the coast. We'll look at the science behind these waves and the incredible forces that set them in motion. We'll also see how scientists use technology to detect tsunamis early, giving people precious time to evacuate and stay safe. From deep-sea sensors to global warning networks, science is helping us stay one step ahead of disaster. Knowledge is power. Understanding tsunamis is the first step to being prepared. Communities around the world practice drills and teach kids about what to do if a tsunami warning is issued. Knowing evacuation routes, having emergency kits ready, and listening to official warnings can make all the difference when every second counts. So, let's make a splash and uncover the science behind these incredible waves. There's so much to learn, and every fact brings us closer to understanding our dynamic planet. Our planet is always changing, and tsunamis are one of its most powerful expressions. They remind us of the ocean's strength and the importance of respecting nature. Ready to dive in? Let's go explore the mighty science of tsunamis together. Most tsunamis begin with a massive undersea earthquake deep beneath the ocean's surface. These powerful quakes are the most common cause of tsunamis, and they can unleash enormous energy in just seconds. Earth's crust is made up of huge interlocking slabs called tectonic plates. These plates are constantly, though very slowly, shifting and grinding against each other as they float atop the semi-fluid mantle below. Sometimes these plates get stuck at their edges, unable to move past each other. Over years, or even centuries, immense pressure builds up at these locked boundaries, storing energy like a coiled spring. When the stress finally becomes too great, the plates suddenly slip, releasing all that pent-up energy in a violent jolt. This is what we experience as an earthquake. If the movement forces one plate to thrust upward, it pushes the seafloor, and the water above it, upward as well. This sudden vertical shift displaces a massive volume of water, setting off a series of waves that race outward in all directions. This is the classic trigger for a tsunami. A dramatic example is the 2004 Indian Ocean tsunami. A colossal magnitude 9.1 earthquake struck when the Indian plate slid beneath the Burma plate, lifting the seafloor by several meters. The resulting tsunami sent waves racing across the ocean at jetliner speeds, devastating coastlines and communities thousands of kilometers away. But not every underwater earthquake causes a tsunami. It's the vertical movement, when the seafloor is lifted or dropped, that matters most. Many quakes only shake the ground side to side, barely disturbing the water above. If tectonic plates simply slide past each other horizontally, there's little or no water displacement, and no tsunami is generated. The direction and type of movement are crucial. Only strong, sudden, upward jolts of the seafloor create the massive, fast-moving waves we recognize as tsunamis. These waves can travel across entire oceans, growing taller and more dangerous as they approach land. Scientists use seismic data and ocean sensors to quickly determine which earthquakes are likely to generate tsunamis, helping to provide early warnings and save lives. Understanding these triggers is crucial for early warning systems, giving people precious minutes to evacuate and reach safety. The more we learn about what sets off tsunamis, the better we can prepare our communities and protect lives when disaster strikes. But earthquakes aren't the only triggers. Let's explore what else can set off these giant destructive waves. Earthquakes aren't the only tsunami triggers. Underwater landslides can send huge amounts of rock and mud tumbling, pushing water aside and creating waves. Volcanic eruptions, especially when a volcano collapses into the sea, can also unleash tsunamis, like Krakatoa in 1883. Rarely, even asteroid impacts can cause mega tsunamis, as happened when the dinosaurs went extinct. The common thread? Rapid, massive displacement of water. By studying geology, volcanology, and astronomy, scientists track all these risks. Tsunamis remind us how interconnected Earth's systems are. Science is a team effort. Now let's follow a tsunami's journey across the ocean. In the vast expanse of the deep ocean, a tsunami is almost invisible to the naked eye, just a fast-moving swell, barely a meter high, blending seamlessly with the surrounding waves. Out here, it's easy to mistake a tsunami for an ordinary ripple, as the water's surface remains deceptively calm and undisturbed. But beneath this calm, the tsunami travels at astonishing speeds, sometimes as fast as a commercial jetliner, racing across entire oceans in just a few hours. This immense energy, hidden below the surface, can cross thousands of kilometers without losing much strength. As the wave approaches land, everything changes. The seabed rises, forcing the wave to slow down dramatically. This sudden deceleration causes the water to pile up, and the wave grows rapidly taller, transforming from a gentle swell into something far more menacing. This process is known as wave shoaling. It's what turns a subtle, almost unnoticeable swell into a towering wall of water that can dwarf buildings and sweep away everything in its path. When a tsunami finally reaches the coast, it can rise to staggering heights, 10, 20, or even 30 meters tall. The sheer force of this water is enough to reshape entire landscapes and devastate communities in seconds. And it's not just a single wave. Tsunamis often arrive as a series of waves, sometimes minutes apart. The first wave may not be the largest. In fact, the most destructive wave can come later, catching people off guard. To protect coastal communities, early warning systems use specialized ocean buoys and sensors to detect these waves far from shore. These high-tech devices monitor subtle changes in water pressure and movement, sending real-time data to scientists and emergency officials. By understanding how tsunamis transform as they travel, scientists can predict their arrival times and potential impact zones. This knowledge is crucial for issuing timely warnings and organizing evacuations that save lives. Science turns subtle ocean signals into life-saving alerts, translating complex data into clear warnings for the public. That's the power of observation and technology, using innovation to stay one step ahead of nature's most powerful forces. But what happens when a tsunami finally reaches land? The true test of preparation and resilience begins as the wave crashes ashore. The real danger is just beginning. Floodwaters surge inland, carrying debris and causing widespread destruction in a matter of moments. Here's what you need to know to stay safe when a tsunami threatens your community. When a tsunami hits shore, it's not a typical breaking wave. It's a fast-moving surge that floods inland like a river. The force is immense, millions of tons of water smashing through buildings, trees, and cars. The water is filled with debris, making it even more destructive. Sometimes the ocean pulls back dramatically before the first wave, a critical warning sign to run for higher ground. After the surge, water rushes back out to sea, dragging debris and people with it. This cycle can repeat with each wave in the tsunami train. The destruction is relentless and chaotic. Recognizing the signs and acting fast can save lives. Tsunamis are nature's most powerful floods. Let's look at what they leave behind. After a tsunami, devastation is everywhere. Homes, roads, and entire towns can be wiped out. Saltwater contaminates drinking water and farmland, making recovery even harder. Coastal ecosystems like coral reefs and mangroves are often destroyed, removing natural barriers. Survivors face disease outbreaks due to contaminated water and crowded shelters. Rebuilding takes years, not just to restore buildings, but to heal communities and the environment. Relief efforts focus on clean water, sanitation, and medical care, Recovery means building back stronger and smarter with better warning systems and education. The scars, physical and emotional, can last a lifetime. But science and preparation help communities recover and become more resilient. Now, let's talk about how nature warns us before a tsunami strikes. Before modern technology, people relied on nature's warnings. A strong, long-lasting earthquake near the coast is a major red flag. Move to higher ground immediately. Watch for the ocean suddenly receding or rising fast. Both signal a tsunami is coming. Animals sometimes sense danger first, fleeing inland or acting strangely. Survivors often describe a loud roar like a freight train, just before the wave hits. These natural signs can save your life if you act quickly. Don't wait for an official alert. Trust your senses and get to safety. Nature's cues are ancient but still vital. Next, let's build your tsunami action plan. Preparation is your best defense. If you live or visit a tsunami-prone coast, know if you're in a hazard zone and learn your evacuation route. At the first sign, earthquake, receding ocean, or official warning, head to high ground or move inland fast. Don't wait to see the wave, seconds count. If you can't escape horizontally, go up. Find a sturdy tall building. Stay put until authorities say it's safe. Tsunamis come in waves hours apart. Afterward, beware of hazards like downed power lines and contaminated water. Keep a disaster kit and practice your plan with your family. Your life is more important than possessions. Leave them behind. Help others if you can, but don't delay. Listen for updates from emergency services. Being prepared and practicing your plan saves lives. Science-based action is your best strategy. We've explored the science and impact of tsunamis, from their causes to their devastating aftermath. Science gives us tools like dart buoys and early warning systems, turning knowledge into life-saving action. Recognizing natural signs and having a plan makes all the difference. Understanding tsunamis isn't just about facts, it's about respect for nature and responsibility for safety. By learning, preparing, and working together, we build stronger, more resilient communities. The Earth will always change, but with science we can be ready. Stay curious, stay prepared. Bill Nye, signing off.